here we have a situation in the village where we want to integrate our ventilation. We want to make sure these people are getting fresh air. We'll also make sure that they stay warm. And we want to combine them because we don't want the situation where people turn the heat on and turn off the HRVs. And this makes it impossible for that to happen, because if your HRV's on, then you're going to get airflow across this heat exchanger and you're going to have a warm house. If the HRV's off, you're not going to get any heat in that house in an effective manner. The first thing is the HRV, the heat recovery ventilator, and in our case we're using this little Venmar Eco, and we have it set up here to kind of do a bench test in the shop. We bring our cold, fresh air from outside, we recover some of the heat that would be coming from the inside going out, and now this is just supply air that would normally go to all of the rooms in the house. But we're doing something a little different here. We're bringing it into this filter box. This is just a place we can filter out the air. And then right inside here, there's a heat exchanger in here, kind of like a radiator in your car. And the idea is that if we pump hot water through this heat exchanger, then it's just going to warm the air that moves across that heat exchanger from, say, 40 degrees Fahrenheit to maybe 90 or 100 degrees Fahrenheit. So now we've got this warm air and it's delivered to your room. What's heating it is this modulating condensing boiler. It has the ability to produce hot water and space heating. It provides it at low temperature, generally it's low temperature fluid. And since we live in this house is going to be a house with low heating loads, we can take the low temperature water. The concept in theory isn't new. You know, it's something that is well, it should be done in a lot of places. But I think what happens is people find reasons not to use heat recovery ventilators. You know, and it's something that needs to be done, in my opinion. You know, especially in Alaska, where we're starting to get tighter and tighter houses. We're getting less and less fresh air through infiltration, so we got to bring in mechanical ventilation. Oh, instead of just bringing in cold fresh air, let's go ahead and recover that heat. So we're kind of killing two birds with one stone. It's going to be shipped out, I believe, next week. So we're bench testing it here to make sure that we work out any gremlins that may show up. The construction of this house in Buckland begins in about a week and a half.
In at 25, going in at 58. How's it feel? It says it's 139 air temperature.
It feels warm.
It's like a head dryer.
That's it?
Head dryer.
Yeah, exactly. Perfect height.
You could put an aerostat right here.
Nice and quiet, nice and warm, nice and quiet. And this is just from the HRV. It's a nice velocity, isn't it?
Not bad. Yep, not bad.
It'll come on and it'll shoot some nice air through the house, and the house will warm up and it'll stay there. And an hour later it'll come on for a little while. Just be off. That's the beauty of this thing. Yeah. When it's off, it's off. It's off, it's off. Okay, you guys. Thanks. Thanks, Jim. It's like we got a system.